Hello and welcome to the second Reigate Maths video on the critical path analysis topic from the first year of the Edexcel Decision 1 unit. My name's Simon, and in this video we're going to be looking at the early and late times of activities in a project for the purpose of finding the duration of a whole project. If you haven't watched the first video yet, you really should, as that'll be focusing on how to draw an activity network, which will be a big part of this video. I'll put the link in the description below for you to go back and view that if you haven't yet. So what are we talking about when we're looking at durations? So the duration is simply the length of time it takes for an activity to finish. Typically, they're denoted on a network using a bracket following the name of the activity. So the example here is if activity A takes 2 hours to complete, the arc will be labelled as A brackets 2. By definition, dummy activities have 0 duration. These may also be given in a precedence table. So when calculating the overall duration of a project, 2 specific times are needed. The early event time, which is the earliest time of arrival at an event, allowing for completion of all preceding activities. So we work this out by starting from 0 at the source node and summing the durations as we go. This is called a forward pass, and if you have multiple options going into an event, you choose the largest total. The number you get at the end is the duration of the whole project. The late event times are the latest time that an event can be left without extending the completion time for the project. So it's the latest time an event could possibly finish. This is called we calculate this using a backwards pass, and we start at the sync node and work backwards towards the source, subtracting the durations. Again, if you might have multiple options going into a specific event, you choose the smallest in our backwards pass. The layout for this is we still use an activity network, but we replace the numbered events with boxes that look like this, where the top box is the early event time and the bottom box is the late event time. So when you're answering one of these questions, you'll fill in all of the top boxes first, and then all of the bottom boxes second, using your backwards pass. So let's look at an example of how this actually works. So this is the example we're going to look at. In this example, we've been given the activity network. You might have to draw it yourself, but if you're not, you will be given it in the exam, so you don't need to worry about drawing it yourself. The question may well be split into 2 parts. Complete a forward, part A, and backwards, part B, pass to find the overall completion time for the project, but it might be like this in sort of one question itself. Typically, it's 2 marks for each. Complete a forward pass. So we've got to do the forward pass first. So let's start there. So we start from 0 at the source node. Very simple. We then go along the arcs, and we can see that 0 plus the duration of A is 2. 0 plus the duration of B is 7. This is now where we start to get multiple options. Not here, because we can see that the only activity that goes into this event is C. So we know that to get to here, to get to that event, it's going to take 6 hours, let's say. But here, into this event, in the middle, we have 2 options. We've got A, D, so that's one path, or we've got B, and then our dummy. A plus D is 5, B plus our dummy is 7, and we want the largest total. So that's going to be 7 there. now we've only got one more event to complete. And we can see we've got three options. 6 plus 2 is 8. 7 plus 4 is 11. 7 plus 1 is 8. So we choose the 11. So we can see that the completion time of the project is 11. Days, hours, whatever the unit of time it is. So that's our forward pass completed. We have done all of the early event times. We now need to do a backward pass to fill in the bottom boxes. So we start at the end and we put in the same number. So you'll notice that these will always be the same number. If you don't get that, you've done it wrong. Let's do the easy ones first. So we've got here, this event has only one arc coming out of it. So we know the late time is going to be 11 minus 2, so 9. These are not always the same. Okay, so the ones at the end, so in our sync node, those will always be equal because we choose it to be that. As we go through, some you'll have the same number, some you won't, and we can see we don't here. This event here, only F goes into it, so we've got F, so 11 minus 4 is 7. These ones are the same, so it's not always the same, but sometimes is. We now have two options going into this event here. 9 minus 4 is 5. 7 minus 3 is 4, and we want the smallest number, so 4. Remember, biggest going forward, smallest going backwards. Here again, we've got two options, 7 minus 0, 11 minus 1, smallest is 7, and then the smallest going backwards is 0. And we can see that our source node is always going to be 0, 0. Now there are a few different points about this that we're going to look at in more detail in subsequent videos. We can see that F starts at an event where the numbers are the same, finishes at an event where the numbers are the same, and we used this number to calculate all the numbers. F is therefore quite an important activity, which we will refer to as a critical activity. And the next video is going to look in more detail at critical activities and what we do with them. But that's just sort of a heads up of something you may well notice about activity F. But that's it. That's how you complete a forward and a backward pass. The next video is going to be a little bit longer, looking specifically at critical activities and then what makes a critical path. Thank you for watching.